overall phone and data traffic is increasing by 115% per year worldwide. To cope with this growth, optical technology is unrivaled, whether for submarine, terrestrial, or metropolitan distances. Optical technology means that, at some point, electrical data is converted into optical data. The conversion is performed inside the transmitter. To transmit high volumes of data, all sources can be combined in a single pipe. This is performed by the wavelength division multiplexing technique. A set of lasers stimulated by different colors are combined into one signal in the transmission fiber. Each laser carries optical data encoded by a specific component called a modulator. In today's systems, modulators operate up to 10 gigabits per second, but can be increased up to 40 gigabits per second.
With its current WDM platforms, Alcatel is proposing its customers with leading-edge technologies and flexible solutions featuring rates up to 40 gigabit per second. To stay ahead of the technology, our research is working on improving 40 gigabit per second technologies into two main directions: performance and cost.
Alcatel is at the forefront of optical transmission research at 40 gigabit, with 10 successive transmission records obtained in the lab, including the latest where we transmit 40 wavelengths over 11,000 kilometers. It's like having 15 million people using broadband internet at the same time across the Pacific Ocean using a single tiny thin hair like this one. But 40 gigabit technology is more challenging than 10 gigabit technology, so we need to investigate alternative technologies to maintain performance.
Most of today's 40 gigabits per second modulators encode 0 and 1 bits into light and no light. A more advanced technique is to encode them into -1 and +1. This latter format is called differential phase shift keying, or DPSK. Research studies have shown that it can double the achievable transmission distance. The signal would fade away in the optical fiber without optical amplifiers. Current amplifiers are based on erbium. A new technology called Raman amplification has been enhanced by Alcatel's research. It could lead to the doubling of achievable transmission distances. At 40 gigabits per second, the impact of chromatic or polarization dispersion is stronger. More sophisticated compensators are needed, either optical or electrical, like those developed by Alcatel Research.
Our main target is to prepare transport transmission systems for sustaining the continuous growth of the transmitted information. With our intensive studies and lab experiments, we have acquired the mastery of the key technologies needed to design transmission platforms at 40 gigabit per second and beyond.
The Alcatel Thales 3.5 lab, working closely with Alcatel Research, has a leading position in R&D components and strong experience in industrial transfers. The lab delivers critical 40 gigabits per second devices, such as microelectronic circuits, as well as optoelectronic transmitters and receivers, for a high added value and cost-efficient solution.
Our objective is to design a high-performance 40 gigabit system that would be less costly than 4 current 10 gigabit systems. In addition, we want to offer a solution providing a smooth migration. It will be compatible with the Alcatel Optical platform and standard telecom infrastructures.